Hi friends, so today we are going to discuss about the unit commitment. So what is unit commitment in power system operation control? So in each generating station, so we have the more than one unit, okay, in different rating. So that one unit means that is for it's a generating unit, okay, so 6.6 kilowatt generating unit, or in 11 kilowatt generating unit, or 6.3 kilowatt unit, okay. So there is different generating unit we have, okay. So based on the demand, okay, based on the need of power, okay, if the power, for example, if the generating unit, one generating unit is it's 300 kilowatt, second one is for say 500 kilowatt, third one is for say 700 kilowatt, okay, 300, 500, 700, okay. I need the power demand at a time for the 1000 kilowatt means, okay, I have to operate the unit 1 and unit 3, 300 kilowatt and at 700 kilowatt. No need to operate the 500 kilowatt of generating unit, okay. So it's simply, so based on the demand, I have to commit the generating unit, okay. Which generating unit commit first and which generating unit commit second, okay. So that is called as unit commitment, okay. So it is necessary to decide which generator or to start up first, okay, when to connect them to the network, and then the sequence in which the operating unit should be shut down, okay, and how long it should be operated. So these points will be considered in the unit commitment, okay. Simply in the unit commitment means, so based on the demand I have to commit the generating unit, okay, give the priority of the generating unit, okay, which generating unit commit first and which generating unit commit second and third, so on, okay. So that is called as unit commitment. So what is the need for unit commitment? So the need for unit commitment is enough units will be committed to supply the system load, and the another one is to reduce the losses on the fuel cost, okay. The operating fuel cost, operating cost is prime important, okay. So to reduce the losses and also to reduce the fuel cost. And third one is nothing but by running the most economic unit, the load can be supplied by that unit operating closer to its best efficiency, okay. So these are the points will be considered for the need of the unit commitment, okay. So what is the difficulties we have to find out during the unit commitment solution? So it is a time consuming process, it will take some additional time, okay. And in complex bus system, okay, normally for the power network, n number of generating unit will be connected, n number of transmission line is there, n number of transformer is there, different rating of transformer is there. It's a complex bus systems, okay. In complex bus system, if the number of units are more, the number of combinations is also it's more. It's one of the difficulties. And third one is, if n is nothing but the number of units, then the number of combinations will be 2n minus 1, okay. So these are some of the difficulties we find out in the unit commitment solutions. And for finally, what are the constraints will be considered for the unit commitment, okay. First one is for it's a spinning reserve, so one of the constraints, okay. So and then for thermal constraints, so comes under the minimums of time, to find out the minimum downtime, and crew constraints also you have to calculate, okay. So some other constraints also will be considered in the unit commitment, that is called as hydro constraints, Mustern constraints, and the fuel constraints, okay. So these are the constraints will be considered in the unit commitment, okay. So what is in spinning reserve, okay. In spinning reserve constraints, in spinning reserve is the total amount of generation available from all units synchronized on the system minus the present load and losses being supplied, okay. So nothing but the spinning reserve constraints, okay. And for thermal unit constraints means we have to consider the minimum uptime, okay. Once the unit is running, it should not be turned off immediately, okay. That is called as minimum uptime, okay. Minimum downtime means once the unit is decommitted, okay. Decommitted means switch off the unit means there is a minimum time before it can be recommit. It will take the minimum time to recommit, okay. That comes under the minimum downtime. Crew constraint means if the plant consists of 2 or more units, they both cannot be turned on at the same time and turned off at the same time. Okay, there are the since there are not enough crew members to attend both units while starting up. Okay, so that is called as crew constraints. Okay, and then we have to consider the startup cost. Okay, so when the startup the cost the already we discussed, the main prime role is for the minimum cost, how it is possible to satisfy the demand. Okay, so in the constraint will be considered the cost also. Okay, the startup cost when banking, startup cost when the cooling. Okay, that is also will be considered based on that formula. I have to calculate the startup cost when cooling and startup cost when banking. Okay. And finally, for the other constraints, that is called as hydro constraints, must constraints, and all will be considered comes under the fuel constraints. These all the constraints comes under the other constraints. Okay, thank you.